today we're moving on to the hyperbola. This is quite a difficult one. It might take a while, but you guys just need to bear with me, okay? Right, so equation of a linear graph. Y equals mx plus c. Equation of a hyperbola. A parabola or quadratic. Y equals ax squared plus c. And the equation now for a hyperbola is going to be y equals a over x plus q. The reason why, now do you see why we use c for the linear and for the quadratic is because this q does not represent the same as a linear or a quadratic. That plus c in those two previous functions both represent my y-intercepts. Where for a hyperbola, it doesn't. Okay, so let's quickly just deconstruct our general rule, general equation for a hyperbola. Okay, so y equals a over x plus q. This x and this y, you know now, just acts as a coordinate on the graph. Okay. This a value over here, we know the m in linear represents the gradient. We know the a in a quadratic tells me if it's a smiley or a sad face. Okay? The a in a hyperbola is going to tell me the shape. The shape meaning, quickly have a look. You see hyperbola consists of two arms. Okay? Always. Okay? Always two arms. If a is greater than 0, meaning it's positive. It's going to lie in the first, the two arms of my graph is going to lie in the first and third quadrants. Can you see here? My first quadrant and my third quadrant. Okay? Right. If A is less than 0, meaning it's negative. Okay, it's going to lie, the two arms of my hyperbola is going to lie in the second and fourth quadrants. Okay. Right, meaning if that number is minus 2, minus 3, minus 5, minus 10, okay, it's going to lie in the second and the fourth quadrant. Okay, moving on. Moving on, we then have what Q represents. Q represents something completely new. A new term is the horizontal asymptote. Okay, now you're going to say it to your man, but what is an asymptote? Okay, can anyone tell me what an asymptote is? Okay, so an asymptote is a place on the Cartesian plane where the graph will never cross. Okay, so an asymptote is where the graph never crosses. So it will never pass through that line. Okay. Now we know horizontal asymptote is the one that looks like this. Okay, that's going to be a line that's drawn like that. In grade 10, we also have a vertical asymptote. Okay, so how the domain of a quadratic in grade 10 is always x is an element of real numbers. In grade 10, the vertical asymptote of a parabola will always be the y-axis. Okay, so in grade 10, it will always be the y-axis. But we know the y-axis is the x equals 0 line, right? Okay. So we know the y-axis is the x equals 0 line. Right, so having a look, remember when they tell you to sketch, you're first going to have a look at the equation and you're kind of going to interpret what they give you so you have an idea of what this thing's going to look like. Okay? So, this is what I'm going to give you in a test. Sketch that. Okay, so first things first, you need to know what you're sketching. Is this a linear? No. Is it quadratic? No, because my exponent for x is 2. Okay, it's a hyperbola, hyperbolic function. Okay, so let's have a look at what they tell us here. We know that x and y has no relevance for now because it just represents a coordinate. Okay, but a over here is positive. And if a is positive, it's going to line which two quadrants? Quadrant 1 and 3. Do you see? So we know this is where our graph needs to lie. The two arms of my hyperbola need to lie in quadrant 1 and quadrant 3. Okay. But what else do they tell us? They also tell us that the horizontal asymptote is where y is equals to negative 1. Yes. This is Q. So we know this is the line that goes that way. It's the horizontal one. Okay. Okay, so what's going to happen is when you're going to have to sketch a hyperbola, you're going to interpret which quadrant it's in, and you're going to write your two asymptotes down. The one asymptote is going to stay the same. The x equals 0, 1. It doesn't change. And the horizontal one, which is going to be given in the equation. Okay. Right. Over and above what they give us in the equation, we need an x and a y-intercept. But now the problem is, in a hyperbola, the y-axis is always an asymptote. Right? The y-axis, the x equals 0, look here. We've got two asymptotes. Okay, we wrote it down, which is the y-axis, is an asymptote. The graph is never going to cut there. So are we going to have a y-intercept for a hyperbola? No. Because that y-axis is like forbidden land for a hyperbola. It's never going to cross there. So we aren't going to have a y-intercept for a hyperbola. Because the y-intercept is an asymptote. Do you understand? Okay, so what we're going to do is, we're going to go and find, do you see, look here? There is no y-intercept in grade 10. There is no y-intercept because the y-intercept, or the y-axis, which is your x equals 0 line, is always an asymptote. Okay, do you understand? Do you see there? Okay, so the reason why in grade 10 we won't have a y-intercept, so you know like in a linear graph you go find an x and a y-intercept, unless there's no plus c, then you go substitute in 1. Okay, same with the quadratic. The quadratic is if we've got no x-intercept, we'll go substitute in 1. Okay. With the hyperbola, you're never going to go and calculate a y-intercept because we're never going to have one in grade 10. But we still need two coordinates to sketch. Okay, so we'll go find our x-intercept by making y is equals to 0. Okay, so we'll go put in 0 where there's a y. We're back to a normal linear equation. Okay, we'll take that over. 0 plus 1 gives me 1. And then remember this one, it's the same in trig. Where what you're looking for is at the bottom, you just switch them. Okay, so this is the same as saying 2 divided by 1. Okay, you just switch them. Okay, and that's how we get 2. There is our first point. Okay, can you see here it is over here? Can you see there? So x is equals to 2 is our first point. But now the problem is we need at least another point, which is not going to be your y-intercept because we're not going to have one. So we'll just go substituting like we did for the previous graphs. We'll go substituting 1. Okay? Do you see? We need another point. So we'll choose any point, normally 1. So wherever there's an x, I'm going to go and substitute in 1. You go get 1's friend, which is also 1, because 2 divided by 1 is 2, and 2 minus 1 is 1. Therefore, my other coordinates I'm going to use to plot is going to be 1 and 1. Are you with me? Okay. So, if I go back, should I draw this from scratch so you understand what I'm doing? Yes. Okay, so look here. How you'd sketch it in a test is you'll have your center axis, right? What you'll do is you'll go add in your asymptotes, right? How many asymptotes do we have? 2. Okay, our first asymptote, which never changes, is here. Here it is here. Okay, here's my first asymptote. This asymptote is where x equals 0. There's your first mark. Okay, yes, your y-axis is always going to be an asymptote. Okay, your second asymptote you get from the graph, and that is -1, which is here, just for argument's sake. Okay, not drawn to scale. Okay, and an asymptote is always shown with a dotted line. There's your second asymptote. So your asymptote, you label it. It's where y is equals to, because here it's crossing the y-axis at -1. Right, let's go and plot our 2 points. The first point we have was our x-intercept, and that was at 2 and 0, right? Okay, let's call it roughly here. So listen, have a look here. That horizontal asymptote has shifted your quadrants. Do you see? So this dotted line acts as your new x-axis. Do you understand? That's what an asymptote does. Because, watch now, our second point we got is at 1 and 1. So you guys want to say to me, man, but how is this sitting now in my first quadrant if we need to cross it over here? Do you understand? So here would be, normally, this would be your first quadrant. Here and here, right? Do you see there? But now my first quadrant has shifted with my asymptote. So there's my first quadrant now. Do you see? Here's my first quadrant here. This is quadrant 1.
So maybe we ignore the...
Yes. Yes.
So our new x-axis starts at negative.
Okay, so have a look now. Here is the first arm of your hyperbola. Can you see it? Okay, but now we know that with the hyperbola it needs to lie in quadrant 1 and quadrant 3 if a is greater than 0. Now you're going to say to me, ma'am, okay, I know the other part of my hyperbola needs to lie in my third quadrant, which is here now. But now I don't have any points. So how am I going to draw it? All I need you to do is to go add the arm into that quadrant. I don't need any points there. As long as you have these 2 here, I'm happy. Okay, as long as your form in this one is correct, I'm happy because you're going to get a mark for that. If you go draw your graph in like, can I tell you, you guys will think I'm crazy, but I got this sometimes. Okay, but why is that wrong? Is because my graph is cutting through my asymptotes, which it's not allowed to do. So do you see how when you get to the asymptote, your graph starts turning? And it will get as close as possible to your asymptote, but it will never cross. Okay, do you understand? You see why it makes like a curve? Okay, right, next one we're going to sketch. That's what I give you. Okay, so suss it out. Okay, A is Negative 3. So if A is negative, it lies in quadrant 2 and 4. So do you see that's how it's going to look? Depending on your asymptotes, it might shift. It might not look exactly like that, but we know it needs to be quadrant 2 and 4. Okay? Then it also tells me that Q is positive 2. So my horizontal asymptote is where? Y is equal to 2. So do you see here, it says to you that my two asymptotes are where x is equal to 0 and where y is equal to 2. Write it down before you even start drawing. Okay. We know we need to get an x and a y-intercept, but we're never going to have a y-intercept with the hyperbola because the y-intercept is always an asymptote. Yeah, we wrote it down here. Okay, so we're going to go find an x-intercept. We're going to go make x is equals to 0. Okay, we take this plus 2 over, it becomes a minus 2. 0 minus 2 is negative 2. But it seems as if what happened here is that they took this whole fraction over to that side to make it positive. But it makes no difference. Okay, so if we had to do it this way, it was going to be negative 2 is equals to negative 3 over x. You'd swap these two around and you'd have x is equals to negative 3 over negative 2, which is positive 3 over 2. Negative divided by negative is a positive, which is the same thing, you see. Okay, same thing. There's our x-intercept, our first point. Okay, so it's going to be 3 over 2 and 0. Are you with me? Okay, we need another point, which normally is our y-intercept, which we won't have in grade 10. So we'll go substituting x is equals to 1. Okay? X is equals to 1. Negative 3 divided by 1 is negative 3. And negative 3 plus 2 is negative 1. There's our second point. When x is equals to 1, y is equals to negative 1. Okay, so what I'm going to do is don't even look at the sketch. I'll sketch it fresh for you here on the side, so you know what we're doing. Okay, so roughly, remember Cartesian plane will be given to you in your test. Okay, before you even start, we know we've got two asymptotes. Okay, my first asymptote always being the y-axis, which is x is equals to 0. We then have a horizontal asymptote which we get from our equation, and the horizontal asymptote is plus 2. So, where y is equals to 2, let's just call it here. That's where our horizontal asymptote will be. Yeah. Okay, y is equals to 2. I didn't use a ruler, you guys will obviously use a ruler, hey? Okay, my first point is at okay, so that's going to be 1.5, eh? 3 over 2 is about 1.5. So you'll go to 1.5. There's our first point. And our second point is at 1 and negative 1. Okay, now we know, according to our shape, it's going to lie in quadrants 2, which is here. Can you see up here? 2 and 2 and 4. Okay, now please, it's going to be quadrant 2, sorted, and then this one we're just going to go and add in our arm here. Okay, label your graph, h of x, label your important points, and we're good to go. Right, the domain of a hyperbola is x is an element of real numbers. Okay, but can x equal this line over here? Does it ever cross here? Okay, so remember, if you use your ruler. Okay, so the graph goes on the x-axis, and then when the graph gets to where x equals 0, does it cross? So do you agree that my domain for a hyperbola is x is an element of real numbers, but it can't equal 0? It can't equal 0. So, in grade 10, x is an element of real numbers. X cannot equal 0. It will always be like that in grade 10. Because remember, that axis does not move. Right, let's have a look at our range. Okay, so take your ruler and place it on the y-axis. So do you see this graph? Goes from negative infinity, it goes, and it can go as close to the asymptote as possible. Then it kind of like jumps over the asymptote, and it continues again. So do you agree that y is an element of real numbers, but it can't equal your asymptote? Do you see? So y is an element of real numbers, but y cannot equal 2, because 2 is your asymptote. Okay? Parabola has got an axis of symmetry, right? That's the x equals 0 line, quadratic. Okay? With the hyperbola, we've got 2 axes of symmetries. A positive axis of symmetry and a negative axis of symmetry for a hyperbola. Okay, so let's just look at this. Okay, just in general standard form. Okay, we'll have a positive axis of symmetry, which goes that way. No, that's a negative axis of symmetry, and this is a positive axis of symmetry. Okay, so hyperbola, very important. We've got no y-intercept. We've got 2 asymptotes, and we've got 2 axes of symmetries. A positive one and a negative one. Okay, so have a look. You see this is the positive one. And this is the negative one. Just make that a negative, a clear negative. That plus q. Do you see this plus q? What is that? The asymptote that they give you in the equation. So, if in a test I ask you to provide me with the equations of the 2 axis of symmetries, you'll go right down y equals x plus q, y equals negative x plus q. And wherever there's a q, you're just going to go put your asymptote in. If you just give me this straight, I'll be happy. Okay. Okay, and then obviously the asymptotes equations, which I've given you already, I've shown you. Okay, so when you look at it, this one is standard. That one's always there, right? Okay, and this one they'll give you in your equation. So there's your 2 equations. So if you just go right for me 0 and 2, I'm going to mark it wrong. It needs to be an equation. X equals 0 and y equals 2. Okay, just like if in a quadratic I ask you if it's a maximum or minimum. You say it's a minimum where you can't just say 2, you must say y equals 2. Okay.